Alright, let us look at projectile motion. So in projectile motion, we're actually going to find the three types of projection, and we have to know what equation we use on this type of equation. When they ask this question, what am I supposed to do? So the first type of projection that you're going to have is actually the one where a ball is thrown horizontally off the cliff. The second type is actually the one where a ball is being thrown at an angle from the horizontal ground, and the third is actually the one where a ball is thrown at an angle from the cliff. So we're actually going to look at these types of projection, but in this video we're actually going to focus on the first projection. So before we can even go into the first projection, let us look at the equation that we have to know when dealing with problems involving projectile motion. And the first equation is actually final velocity is equal to initial velocity plus acceleration times time. The second equation is actually final velocity squared is equal to initial velocity squared plus 2AD. The third equation is actually d is equal to initial velocity times t plus half at squared. The last but not the least equation is actually d is equal to velocity times time. So we use this equation when we're actually dealing with objects moving with constant speed, while we use these three equations when dealing with objects moving with constant acceleration. So these are actually the equation that we're actually going to use when we're asked to solve the problems involving projectile motion. So let us go into the first projection. The first projection is actually the projection where a ball is actually thrown horizontally off the cliff. So this is actually the first projection. In this type of projection, you'll actually be asked to calculate the time it takes for the ball to move from the point where it was thrown to the ground. So the first thing you'll be asked, or one of the things that you're going to be asked, is to find the time. You'll also be asked to find the height of the cliff. So you also be asked to find the height of the cliff, this height. Apart from the height, you also be asked to find the range, which is the horizontal distance, this distance. And apart from the range, you also be asked to find the speed the ball was moving at before hitting the ground. And apart from that, you also be asked to find the angle. So let us look at what equation we have to use when we have been told to calculate the height. So if you have been given a problem and it involves this type of projection, and then you have been asked or told to find the height or the time, so we use the equation t is equal to v initial times t plus half at squared. In this equation, we actually have to write it in the y-axis. We don't just use it the way it is, we write it in the y direction. So writing this equation in the y direction, we're going to have d in the y is equal to v initial in the y times t plus half at squared, and a, we have to write a in the y-axis. So displacement in the y-axis is actually the height. So it is this, which is the height. I'm going to replace dy with h is equal to velocity in the y-axis, the initial velocity in the y. So the initial velocity in the y-axis, or rather let me just say velocity in the y-axis, at the top, it is actually what? It is actually 0. When velocity in the y is actually at the top, it can either be the initial velocity or maybe the final velocity. As long as it is at the top or at the highest point, then vy is always what? Is always equal to 0. So vy here, it means it's what? It's 0 times t plus half. Acceleration in the y-axis is actually acceleration due to gravity, which is g times t squared. So h is equal to 0 times t is actually 0. So I'm going to have h as half gt squared. So this is actually the equation that we use when we're asked to find the height or the time. So I'm going to write this equation here. h is equal to half gt squared. So apart from the height and the time, you will be asked or might be asked to also calculate for the range in this type of projection. So when you're calculating for the range, we actually use the formula d is equal to vt, and then we write this equation in the x-axis. We wrote the first equation we had in the y-axis, but this equation we are going to write it in the x-axis because we want to calculate what? We want to find the range. So writing this equation in the x-axis, we're going to have d in the x is equal to v in the x times time. So d in the x is actually the range, which is equal to velocity in the x-axis. So this ball was thrown horizontally from the ground, so the same velocity at which the ball was thrown at, since it is horizontal, it is actually basically in the what? In the x-axis. So that is actually the velocity that we get. So we get the same velocity and plug it here. We are still going to name it as our v in the x-axis, and then we're also going to multiply with what? With t. So this is the equation that we use when we're calculating for the range. I'm also going to write this equation here. Range is equal to v in the x times t. So apart from this, you will also be asked to find the speed the ball was moving at before it actually hits the ground. So when finding the speed the ball is moving at before it hits the ground, use the formula v is actually equal to the root of velocity in the x squared plus velocity in the y squared. So looking at this type of projection, we have the velocity in the x, which is actually the velocity at which the ball was thrown at, but we don't have the velocity in the y-axis. So we actually have to calculate the velocity in the y-axis first, and then we calculate the speed the ball was moving at before it actually hits the ground. So when calculating for velocity in the y-axis, we actually use the formula velocity final is equal to velocity initial plus at. And writing this equation in the y-axis, we're going to have v final in the y is equal to v initial in the y plus acceleration in the y times t. So v final in the y-axis is actually the final velocity that we're going to have before the ball hits the ground. So that's actually the velocity that we're looking for. So we're just going to write v final in the y is equal to v initial in the y. It's actually the velocity the ball was moving at in the y-axis when it was thrown, which is actually what? Which is actually 0 plus a in the y-axis. It's what? It's acceleration due to gravity times t. So this gives us that the final velocity in the y-axis is actually acceleration due to gravity times t. So we use this formula to find the final velocity in the y-axis. And after getting the final velocity in the y-axis, we use this formula now to calculate for what? To calculate for the speed the ball was moving at before it actually hits the ground. I'm also going to write these equations here. So v is equal to the root of v squared in the x plus vy squared, and final velocity in the y is equal to acceleration due to gravity times time. So apart from this, the last thing but not the least that you are going to be asked in this type of projection is actually to calculate or to find the angle. So when calculating for the angle, we actually use the formula angle theta is equal to tan inverse of what? Of the velocity in the y-axis over velocity in the x-axis. You already found the velocity in the y-axis using this formula, and the velocity in the x-axis has been given, which is the velocity the ball was thrown at in the x-axis, and you actually just multiply this with the inverse of tan, then you get your angle theta. So these are actually the equations that we have to use when dealing with problems involving projectile motion.